Welcome to this scientific lecture on the Genius Dysfunction Paradox. Today we're going to explore one of the most fascinating contradictions in human cognition. Why do many brilliant minds appear chaotic and disorganized in daily life, yet produce extraordinarily ordered scientific and artistic works? At the heart of this paradox lies a profound question. How can someone who forgets to eat breakfast, loses their keys daily, and keeps a desk buried under papers, simultaneously construct elegant mathematical proofs, or compose symphonies of perfect structural harmony? This pattern appears repeatedly throughout history. From Einstein's famously disheveled appearance to Newton's obsessive work habits that caused him to forget meals, from mathematician Paul Erdos living out of a suitcase to artist Salvador Dali's eccentric routines. Let me give you a powerful analogy. Imagine a master inventor's workshop. To an outsider, it looks like complete chaos. Tools scattered everywhere, half-finished projects piled up, wires tangled, sketches covering every surface. But to the inventor, every single item has its precise purpose and location. That seemingly misplaced wrench is actually positioned exactly where it needs to be for the current project. The scattered papers contain crucial notes in a nonlinear but deeply logical sequence. The inventor's mind has created an intricate map of associations. Each object triggers specific memories, ideas, and connections that would be lost in a sterile, conventionally organized space. Now let's examine the cognitive neuroscience behind this phenomenon. Recent research suggests that what appears as disorder may actually be a highly sophisticated organizational system operating on different principles than conventional order. There are fundamentally two types of cognitive organization: sequential hierarchical organization, which is what most organizational systems use, and what we might call associative network organization, which many creative geniuses employ. Sequential organization follows a strict hierarchy. Step 1 leads to step 2, which leads to step 3. It's linear, predictable, and easy for others to follow. But associative organization works like a web. Every node connects to multiple other nodes through meaning, similarity, or emotional resonance. Here's where it gets mathematically interesting. Let's quantify the difference between these organizational systems using network theory. We can use the clustering coefficient C, which equals 2e divided by n times n minus 1. Here e is the number of connections, and n is the number of nodes or concepts. For a typical well-organized mind using hierarchical thinking, the clustering coefficient is around 0.3. This means about 30% of possible connections exist. But for highly creative minds, studies using fMRI and network analysis suggest clustering coefficients between 0.7 and 0.9. That's more than twice the connectivity. Let's work through a concrete example. Suppose we have 100 concepts in working memory. For a typical mind with C equals 0.3, that's approximately 1,485 connections between concepts. But for a creative mind with C equals 0.9, that's 4,455 connections, 3 times as many pathways between ideas. Now you might ask, if creative minds have more connections and richer organization, why does it appear as disorder to outsiders? The answer lies in how information is retrieved. With so many connections, the path from thought A to thought B might go through thoughts C, M, and Q in ways that seem random to an observer. To reach idea B from idea A, the creative mind might travel through idea C related by emotional association, then to M related by visual similarity, then to Q related by temporal coincidence, before finally arriving at B. This path makes perfect sense internally but looks chaotic externally. Now let's examine another fascinating aspect: the entropy paradox. How can high internal entropy lead to low entropy output? Entropy, from thermodynamics and information theory, measures disorder or randomness in a system. Higher entropy means more disorder. The Shannon entropy S equals negative k times the sum over I of p sub I times the natural log of p sub I. Here p sub I is the probability of state I. In the mind of a genius during the creative process, internal cognitive entropy is very high. Thoughts jump between distant domains, unusual associations form, contradictory ideas coexist. But the final output, whether a mathematical proof, a symphony, or a scientific theory, has very low entropy. It's highly ordered, structured, and elegant. So what's happening? There's a filtering mechanism at work. Think of it like a gold prospector. The prospector sifts through tons of dirt and rocks, high-entropy material, to extract a few nuggets of pure gold, low-entropy output. The genius generates vast quantities of ideas, associations, and possibilities in their chaotic internal process, then rigorously filters them to produce only the most valuable insights. We can define filter efficiency as E input minus E output, all divided by E input. The larger the difference between input entropy and output entropy, the more effective the creative filter. For exceptional creators, this efficiency can reach 95% or higher. They generate 100 ideas, but only publish the top 5, ensuring extraordinarily high-quality output. Let's examine a specific case study, Albert Einstein, and his famous thought experiments. Einstein's notebooks reveal a mind that jumped between physics, philosophy, music, and everyday observations. Einstein would think about relativity while playing violin, ponder light waves while watching boats on a lake, and develop ideas during long, aimless walks. To observers, this seemed unfocused and inefficient. But these seemingly unrelated domains all fed into his central insight about relativity. The rhythm of music informed his sense of space-time symmetry. Observations of moving trains provided concrete analogies. Philosophical questions about simultaneity sharpened his concepts. And from this apparent chaos emerged one of the most elegant equations in all of physics. E equals mc squared. Energy equals mass times the speed of light squared. This equation has maximum elegance, only 3 variables, perfect symmetry, profound implications. Let's appreciate the numerical implications. Consider just 1 kilogram of matter. The speed of light is 3 times 10 to the 8th meters per second. So E equals 1 times 3 times 10 to the 8th squared, which equals 9 times 10 to the 16th joules. That's 90 quadrillion joules from just 1 kilogram. To put this in perspective, that's equivalent to 21 megatons of TNT. 1 kilogram of matter, if completely converted to energy, could power a large city for months. This incredibly ordered, simple, and powerful equation emerged from Einstein's chaotic, nonlinear thinking process. The disorder was not a bug, but a feature that enabled the breakthrough. Let me introduce another key concept, the divergent-convergent cycle that characterizes genius-level creative work. In the divergent phase, the genius allows their mind to wander freely, making unusual connections, exploring bizarre possibilities, embracing contradiction. This is the chaotic workshop phase. Then, in the convergent phase, rigorous analysis, logical filtering, and systematic organization transform the chaos into elegant output. Most people either skip the divergent phase entirely, going straight to conventional solutions, or they don't explore it deeply enough. They fear the disorder and retreat to comfortable, predictable thinking. Geniuses fully commit to both phases. They're willing to appear foolish, distracted, or disorganized during divergence because they understand it's essential for generating truly novel insights. Now here's a critical question. Is this genius dysfunction paradox something innate, or can it be learned and cultivated? The answer appears to be that it's partially trainable. While some individuals may have natural predispositions toward associative thinking, research shows that deliberate practice can increase cognitive flexibility and tolerance for ambiguity. There are 3 key trainable skills. First, tolerance for cognitive dissonance, the ability to hold contradictory ideas simultaneously without distress. Second, associative reach, practice connecting distant concepts across domains. Third, rigorous filtering, developing criteria to separate brilliant insights from mere novelty. Let's do a cost-benefit analysis of the Genius Dysfunction Paradox. What are the trade-offs of this cognitive style? On the cost side, social misunderstanding, challenges in daily life logistics, difficulty collaborating with conventionally organized colleagues, mental exhaustion from maintaining rich associative networks, and appearing unreliable or scattered. On the benefit side, ability to generate truly novel breakthroughs, deep creative insights, exceptional problem-solving across domains, capacity to shift entire paradigms, and lasting intellectual or artistic impact. From society's perspective, the benefits often dramatically outweigh the costs. A single breakthrough from a chaotic genius can transform entire fields and benefit millions of people. But for the individual genius, the trade-off is more complex. Many report feeling isolated, misunderstood, or frustrated by daily life demands that seem trivial compared to their intellectual pursuits. What are the implications of understanding this paradox for education and workplace design? Current educational and workplace systems are heavily optimized for sequential hierarchical organization. They often penalize or pathologize the very cognitive styles that generate breakthrough insights. Students with rich associative thinking are labeled as distracted, unfocused, or disorganized. Their divergent cognitive style is treated as a deficit rather than a different valid approach. Workplaces demand constant visible productivity and clear, linear progress. The apparently unproductive wandering essential for creative breakthroughs is discouraged or prohibited. Understanding the Genius Dysfunction Paradox suggests we need to redesign these environments, create protected time and space for divergent exploration. Value depth of insight over superficial productivity metrics. Allow for personalized organizational systems rather than imposing one-size-fits-all order. There's an important connection between the Genius Dysfunction Paradox and neurodivergence, particularly ADHD and autism spectrum conditions. Research shows significant overlap between the cognitive profiles of highly creative individuals and those with certain neurodivergent conditions. Both show enhanced connectivity in some brain networks, unusual attention patterns, and difficulty with conventional organization. This doesn't mean all neurodivergent people are geniuses or all geniuses are neurodivergent, but it suggests that some traits labeled as disorders may actually be alternate cognitive architectures with both costs and benefits. This reframes deficit models of neurodivergence. Instead of seeing only impairment, we can recognize that some minds are optimized for different types of problems, not broken conventional minds, but highly specialized creative minds. Let's develop a simple mathematical model of information processing in conventional versus genius-style cognition. Information output equals ETA times information input times F. Here, ETA is processing efficiency, I input is information absorbed, and F is the filter quality factor. For conventional thinking, processing efficiency ETA is high, around 0.9. You efficiently process information in standard ways. Filter quality F is moderate, around 0.5. You filter out about half as noise. So if input is 100 units, conventional output is 0.9 times 100 times 0.5 equals 45 units of useful information. For genius-style thinking, processing efficiency might be lower, say 0.6, because of the chaotic nonlinear processing. But information input is much higher, say 500 units, because of broader associative reach. And filter quality is much higher, say 0.9, keeping only the very best insights. So genius output is 0.6 times 500 times 0.9 equals 270 units. 6 times more useful output despite appearing less efficient. The key insight from this model, genius-style cognition, succeeds not through conventional efficiency, but through massive information intake and exceptional filtering. The apparent dysfunction is actually exploring a much larger solution space. Let me give you another concrete example. Richard Feynman and his famous diagrams in quantum electrodynamics. Feynman was legendary for his unconventional approach to physics and life. He played bongo drums, frequented strip clubs to think, picked locks as a hobby, and drew pictures instead of equations. His famous Feynman diagrams transform hideously complex quantum mechanical calculations into simple visual pictures. An electron travels here, emits a photon there, and the whole interaction becomes visually intuitive. Feynman developed these diagrams not through systematic study but through playful exploration. He watched plates spinning in the cafeteria and wondered about wobbling motion, leading to insights about electron behavior. Pure creative disorder generating pure mathematical order. The impact. Thousands of papers across particle physics use Feynman diagrams. They revolutionized how physicists think about quantum interactions, making calculations that would take pages of algebra into simple visual reasoning. This raises a profound question. Is the disorder actually necessary, or is it just correlated with genius? The answer seems to be that a certain amount of disorder is functionally necessary. Overly rigid organization constrains thinking to conventional paths. Disorder allows exploration of vast solution spaces that rigid systems would never access. Think of simulated annealing and computational optimization. You deliberately add randomness to escape local minima and find global optima. Creative disorder serves a similar function in human cognition. Without disorder, you get stuck in local minima. Good solutions, but not optimal. Strategic disorder lets you escape and find the global optimum, the truly brilliant solution that rigid thinking would never discover. Let me summarize the key insights we've explored about the Genius Dysfunction Paradox. First, what appears as disorder or dysfunction often masks a highly sophisticated organizational system based on associative networks rather than linear hierarchies. Second, high internal cognitive entropy during the creative process can generate low-entropy, elegant output through rigorous filtering. The messy workshop produces refined products. Third, genius-level cognition succeeds by processing vastly more information across broader domains, then applying exceptional filters, not by being conventionally efficient. Fourth, the divergent-convergent cycle is essential. Full commitment to chaotic exploration, followed by rigorous refinement, produces breakthroughs that purely orderly thinking cannot achieve. Fifth, understanding this paradox has profound implications for education, workplace design, and how we value different cognitive styles. We need environments that support divergent exploration, not just convergent productivity. The Genius Dysfunction Paradox teaches us something profound about the nature of creativity and innovation. Order and disorder are not opposites, but complementary partners in the creative process. The most ordered outputs emerge from the most chaotic internal processes. The messy workshop is not a quirk that exists despite the inventor's brilliance. It is an essential component of that brilliance, the physical manifestation of a mind exploring vast solution spaces. Perhaps most importantly, we must learn to value process diversity as much as we value output excellence. Not everyone should or can work this way, but those who do should be supported rather than forced into conventional molds. The dysfunction is not a bug in the system. It is a feature that enables the system to generate outputs that orderly systems cannot produce. Understanding and embracing this paradox may be essential for fostering the next generation of breakthrough thinkers.